So this is kind of bittersweet, folks. This is the last day we will be taking notes in this class. So next week is mostly going to be preparation for the final, in addition to a documentary / movie on aliens that you should look forward to. Is it going to be what? Alien? No. So we ended here with the Saturn V rocket. It is massive. This was the last thing you should have had in your notes. 58 feet taller than the Statue of Liberty. That is one big rocket. And I strongly urge you, keep it down a little bit, folks. Keep it down, please. I strongly urge you at some point in your lives, stand next to this thing, and you'll get an idea of the scale and how much is involved in it and how much we needed in order to actually make it all the way to the moon and back. This is, you can find these mostly in the South. In Texas and Florida, they have museums that have them, because most of these rockets are launched from Cape Canaveral in Florida. So. You don't have to write any of this down, but what I would like you to kind of take away from this is that that rocket did not go all the way up to the moon and then fly all the way back to the Earth. There were lots of different spots where parts of it fell away, and you basically continue to get a smaller and smaller rocket over time. After a period of time, this part of the rocket falls away, and then after a little bit longer, this part falls away, and then this part falls away. They each have their own purposes in order to get what's up here, the people, to the moon and then back home. And that takes place over a certain amount of time. It's after 2 minutes, basically, that the first stage falls away. And the second stage falls away 30 seconds later. And then after that, other things happen. You don't need to write any of this down. Okay, in terms of these Apollo missions here, go ahead and write down the goal for Apollo 1. So when we're dealing with these Apollo programs, then, it's not like this was our first attempt to get to the moon. Apollo 1, you know, the main thing is to make sure everything actually works the way you want it to work before you do that. So their goal was to orbit the Earth, check life support, all that stuff. Well, it seems like a kind of a good group of guys in Apollo 1. And you heard a little bit about what happened with Apollo 1 when we watched Apollo 13 a while back. They hadn't even gone into space yet, and what ended up happening is they were running a test inside the capsule on the launch pad. It wasn't even launch day or anything. And they had a complete oxygen atmosphere on the inside, and there was a spark because there was a lot of faulty wiring in there. And the spark in a pure oxygen atmosphere quickly escalated to a full-on blaze. And those astronauts were killed in that fire in 1967. They couldn't get the door open, and furthermore, when you have the fire eat up all that oxygen, it creates a vacuum. So even if the door was unlocked, it would have been very difficult to open. Yes? Yeah, yep. So that was 1967. And this is their memorial. After this, it was slow going for a while, trying to build up the program and trying to, get things back in order to make sure that we weren't rushing things and have another accident. So the next big thing that happened along those lines was Apollo 8. You don't have to write this down. This is, this is one of those missions that really is underrated. It was a huge deal when it happened. Their goal was to be the first group to orbit the moon and return safely to the Earth. So you got your little figure 8 there on their space patch. And they did that in 1968, not long after that fire. They went around the moon, they returned back home, and as they were orbiting the moon on Christmas Eve, you heard in that documentary, In the Shadow of the Moon, they read from the first chapter of Genesis. And they read the entire first chapter, which was really, really cool. It was a lot more than the excerpt that you heard on the documentary. And they were the ones that took that famous Earthrise picture. So check this out. So they were, the first people to see Earth from that perspective. Yeah. This might be the most famous space picture from the moon. Should we see that animation again? Yeah. Going backwards. And then forwards. I was actually given as a gift that's my gift to you. The gift that I got was, it's a picture of Apollo 8, and it's signed by both Jim Lovell and Frank Borman right here. So I have that hanging in my rec room in my basement, which is really cool. Bill Anders, his name wasn't on it. I don't know why. I guess not. But yeah, that's really, really cool. So, that was a huge deal, but of course, the first trip to the moon is going to be overshadowed by the first person walking on the moon, and that's Apollo 11. Go ahead, write down Apollo 11. You don't have to write this down yet. So that was the first mission that we attempted to go to the moon and drop a person in there. And write down Neil Armstrong and Buzz Aldrin walked on the moon. That's all you need to write down from this slide. Neil Armstrong and Buzz Aldrin walked on the moon. Why didn't he go on the moon? Yeah, that is a little sad. And you heard from the documentary, remember, people called him the loneliest man in the universe because he was on the other side of the moon for a while they were walking on the bright side. And he said he didn't feel like that at all. He felt he was very blessed for that experience, and rightfully so. So yeah, Neil Armstrong and Buzz Aldrin walked on the moon. They came down on the LEM, and then when their time was up, after those couple days, the LEM fired off the moon, and it rendezvoused with the command module, and they all headed back to Earth safely. I don't know. I think it was probably an upper management decision. I'm not sure. I don't know why they picked Neil, but if you're talking about a guy who really is steady in the face of anything dangerous, he'd be the guy. Him and Jim Lovell were extremely exceptional pilots and astronauts. So you can see there's a picture of the footprint left. Flag there. The next notable mission that we'll just have you write something down about is Apollo 13. You probably know where this is going. Write down Apollo 13. So here you have Jim Lovell, Fred Hayes, and Jack Swigert. If you remember them from the movie, this was Tom Hanks. Yeah, Kevin Bacon was him. What was that? Wasn't Kevin Bacon what?
Oh, Jack, that's what I...
Yeah, he was Jack. So this was Kevin Bacon, yep. So their goal was to, just like Apollo 11, walk on the moon and come back. Just write down liquid oxygen tank explosion. And of course, you know about everything that happened there. There are several books written on it too. One I have is called "Failure is Not an Option" by Gene Kranz, the flight director. Really interesting read. So this is an actual picture, and you can see from the picture they showed in the movie, this was not elaborated at all or enhanced. You can see the massive amount of damage that explosion caused, and it is a miracle that those astronauts did not perish immediately after that. It exploded up to the point where if it had gone any further, they would have been goners. So wonderful that they made it back. Oh, sure. About everything that happened there? Oh, yeah. I mean, Jim Lovell has a book on it. I got the one by the flight director, but you could probably just get it over winter from the library or something. That'd be a good read. A good way to kind of forget that you're no longer in astronomy class. And we're not going to be coming back after this semester because astronomy is just a one-semester course, unfortunately. So these were the 3 astronauts of Apollo 13 when they returned, and there's the ship that they were on. Mission Control was, of course, excited. And see, he pretty much looks like the guy from the movie, doesn't he? All right, write down Apollo 17. I don't know. Yeah, they are pretty awesome. Go ahead and write down the goal here. Sure.
What's the number? Okay. What was the difference between the goals in Apollo 11 and Apollo 13?
Not really any difference. They were both just to land someone on the moon and bring him back safely. I think Apollo 11, there were less extra things that they were supposed to do on the surface of the moon. For Apollo 13, they probably had to. They were probably supposed to run some geologic tests and things like that. But yeah, obviously they didn't get a chance to do that.
Didn't they say they were going to pick up like a couple tons of rock?
Yeah, bring back samples. Yes?
Did they need, like, for Apollo 17, did they need, like, more space, like a bigger rocket, actually, because they have, like, the rover?
No, actually, basically what they did is they sacrificed a lot of scientific experiments for that one trip to get the rover there. So that was kind of the main thing of the mission that took the rover. The rover was already here by the time Apollo 17 went up there. I think that was taken up in Apollo 15 or something like that. But yeah. So yeah, test and use the lunar roving vehicle, bring back samples from the lunar surface, and I have some other bits of information from this one. Apollo 17 was the final mission, so the most important thing you should write down from this one is that this guy, Eugene Cernan, he was also in the documentary, same color hair as pretty much what he has now. He was the last man to walk on the moon. Eugene Cernan, last man to walk on the moon. Write that down. And that LRV, the Lunar Roving Vehicle, is quite an ingenious thing. And I'll get to some pictures of that shortly here. A couple of words on that. Some pictures from Apollo 17. You can see the Lunar Roving Vehicle right here. And you can tell, the LEM is not a very big thing. It's a small thing that carries those 2 astronauts down to the surface. Of course, it's in the background a little bit, but yeah, there's the Lunar Roving Vehicle. They did run into some issues with this because on the moon, you don't have nearly as much gravity as you have on Earth. So a lot more of this dust and ground up rock is going to get kicked up. And so it was getting kicked up a lot. It was kind of getting in their gears. So they had to actually, what they did is, I think they actually took part of their flight manual and they fashioned it as sort of a splash guard on the back of those tires to keep the dust from flying up and all over the place. So yeah, they still had to do a little bit of improvising. It's also kind of interesting. You can tell, and I think I might have mentioned this once before, you can tell that this mission was designed by men. Because there's nothing more masculine than going to the moon and being like, let's just take a car there so that we can go drive around for a while. My dad actually has a 1970 Chevelle, and one of our favorite things to do when I go up there in the summer every so often is just ride with him and drive around Oshkosh for a while. It's a good time with the windows down. So yeah, we've got the LRV. It is still there. I don't know if it's still operational, but it should still be on the surface of the moon. And there's a close-up of it. And as mentioned before, we should be heading back to the moon from what I read in 2024. NASA plans to do that. One of the final pictures right there. And on to the Space Shuttle program. Write down Space Shuttle program ultimate goal. Build the International Space Station. So in terms of the Space Shuttle, then a few things. Before we jump into the Space Shuttle, I have actually a model of the Gemini capsule here. And you can see how tight it was on the inside. If you can see the inside here, you got two people in there. That is much smaller than the inside of any compact car today. Not very much room to even move your legs in there. As we got further up in the Apollo program and the Space Shuttle program, you got a lot more space that you could deal with. Now, this was the very first stamp of the very first shuttle that was launched, and that was the Space Shuttle Columbia. And you can see that right here. Write down Columbia, first shuttle launched. You can skip the year. And you'll notice this looks just a little bit different from this space shuttle right here. For the folks at home, I'll see if I can move this in front of the screen without dropping it. I want to make sure that I get light on it too here. So you can see they're clearly different. This one right here, we've got an orange tank, and this one right here, it's white. And the story behind that is they thought it would look cooler if they just painted the thing white. And then they realized how much weight they were adding to the whole system by adding all that paint. And it would actually cost a lot more money to take this up into space because of the massive amount of poundage you've got with just paint. So it wasn't long after this that they decided to stop painting that tank, and that's why most space shuttles you see with an orange tank right here. That's what it looks like when it's not painted. But in the beginning, it was painted. So Columbia, go ahead and write down this. This occurred, I believe, in your lifetimes. You guys were born. What year were you guys born? in this year, in that area anyway. So yeah, Columbia had an enormous disaster, and one of the things that I feel kind of bad about, since we are wrapping up this semester earlier and we've had a lot of virtual days and virtual time, one of the documentaries we were going to watch is on what happened to the Columbia Space Shuttle, and it's really fascinating about what happened and the process of how they end up exploding on re-entry, because this is unlike anything that had ever happened before. Nobody has had an explosion on re-entry until this in 2003, 22 years after the Space Shuttle program started. They thought they had all these kinks worked out. Here's what ended up happening with that. You don't have to write any of this down, but what ended up happening is, this is at launch time, a piece of foam that is like over here. You don't have even edges, and there's pieces of foam that they put in there in order to make the surface a little bit more aerodynamic. Well, a piece of foam came off, and it hit the shuttle right about here in the wing, and it caused an opening probably a couple feet across. And even in 2003, people were complacent. When this was in orbit, after it successfully got up into space, there was no mechanism to actually look around and see any damage on the shuttle. It's kind of crazy to think about that. But they didn't have that capability, and they had no idea when they were coming back into Earth that they had that massive hole in the wing. And what that means then is you have no heat shield in that area. So all that heat goes into the wing, and eventually it just broke the entire wing off, and the whole thing tumbled and started on fire on the way down. Of course, there were no survivors. So yeah, a sad, sad turn of events. And again, it's the sort of thing when you become complacent and when all of your efforts are focused on getting the shuttle to space and to Earth for as little money as possible. So that's a big, big issue. If you don't have the time and the money to dedicate to this, just don't do it. Yeah, and it was a big piece of foam. And the thing is, when it came off, that rocket was going...
Please pardon the interruption. Imani Jordan, please come to the office. Imani Jordan, come to the office, please.
That rocket was going at probably 2 times the speed of sound. So it's booking it up. That piece of foam falls off, and so now it's not going that fast anymore. It just slams right into that wing. So yeah, it's crazy stuff. And when you see the amount of damage that some of these shuttles came back to Earth with, it's pretty crazy that there haven't been more disasters. So this is the crew that we lost back in 2003 then. And here's their memorial. Any guesses on the next thing we got to talk about? Challenger disaster. Write down Challenger. So you can write down takeoff disaster. Again, you can leave out the year. Now, what made this mission even more I don't want to say more disastrous. I mean, they were both just awful. Anytime you lose life, it's just horrible. But what made this one more visible to the public is this was to the point, we were 5 years into the shuttle program, there hadn't been any accidents, no disasters yet. So, NASA's trying to get this idea across that, using the space shuttle, it's very reliable, and it's almost routine. And when you start treating things as routine, bad things can happen, and this was no different. The reason it was such a big shock to everybody, and the reason all of the public's eyes were on this, was because as they were pushing that routine, idea, they decided to send a teacher who wasn't an astronaut up in this mission, Christy McAuliffe. And, of course, she perished along with the rest of the astronauts then. And so, again, that was another shock to everybody. This was, much earlier than the Columbia disaster. But, yeah, anytime you're going up to space, it is not routine, and you should never treat it as such. What happened with the Challenger disaster is they launched during some very, very cold weather, and these SRBs, solid rocket boosters, these are the places where you have the fuel and it all ignites. And, of course, you have the rockets, and the fuel comes out the back of those two solid rocket boosters, these two things right here. And this provides more fuel to those two rockets. And so what ended up happening is on the inside, you have a mechanism that keeps these two parts of that rocket from separating. You have a mechanism so that they are airtight and nothing can get out. Well, it was so cold that mechanism, it's like a little, it's not a washer, but it's something that is supposed to keep that seal. It was so cold that it shrunk, and some of that fuel got out. And you can see a picture of that right here. This is the smoke from the fire that was produced by that fuel. And then as it went up, you can see it got bigger and bigger, and what ended up happening here is that fuel and that fire that was leaking out eventually caused a big enough flame that it burned all the way through this this entire fuel tank. And of course, when you burn through that, the whole thing just exploded. What I would show you on a documentary from this one that we're not going to have time for was actually even more sad. This actually sealed itself on the way up. But what ended up happening is there was a huge jet stream that day in the upper atmosphere. And what ended up happening is it shook the rocket enough that it jarred, they call it slag, it jarred the slag that resealed it free, and then that ended up coming back, and that's when it burned through what was left. Yes?
Did they not notice, like, the smoke starting to form before they took off?
No. This is the sort of thing that you're not going to notice until you're up in the air. I mean, they could see from the camera when they look back that this was happening, but I mean, this is one of about 1,000 cameras that you have on the space shuttle. So just by looking at that smoke, they probably wouldn't have shut it down even if they had seen it right away. Of course, when you see this, at this point it might have been past the point of no return. Because they were up in the air for quite a while. This is not like 15 seconds after launch. This is several minutes. And by the time several minutes have passed, you're almost to space. So it's another really, really sad turn of events. Here's the crew that we lost there. This is the teacher, Krista McAuliffe. And there's their memorial. And there were not just, one or two shuttles. There were a series of shuttles that would go up into space and then come back down. When that one would come back down, people would examine it and, fix whatever needed fixing from the heat shield. Because it's a massive, massive thing. There's a lot of places where things can get dings and stuff like that. So in the process of those being repaired, you had more shuttles that were going up while that was happening. Endeavour was one of those. You can write down Endeavour. Write down that it was Challenger's replacement. And a little bit about what happens with the shuttle. It is basically what it says it is. It's a shuttle. It was made to shuttle people and parts up to the space station, and then this would come back down to Earth. So you have the whole thing going up. After it gets far enough, eventually all three of these tanks fall away. They burn up in the atmosphere on the way down so they don't hit anybody. And then this thing they call the orbiter, and that stays in orbit around the Earth until it's time to come back down. And they have some little rockets on the back that they can use to find their way back to Earth.
I had the coolest toy.
Oh, yeah?
Oh, yeah.
Nice.
You like peel off the space shuttle and all the rockets. You get like 4 rockets.
Oh, sweet.
Yeah.
Oh, that's awesome. Yeah, the space shuttle program was big when I was a kid, too. And the cool thing about all this, though, is this is kind of, there's Endeavour going up there. Well, I'll transition later on. Discovery is the next shuttle. Write down that it flew the Hubble into orbit. Again, don't worry about the year. At any one time, it was between 4 and 5. And in addition to this one, and the next one we'll be talking about, there was actually one more called Enterprise, but it was not operational. It was kind of like the very first designed one that they had on Earth. It was never sent up into space, I don't think. It was at least never sent up with humans. Yeah, we're getting down there. We have one more shuttle, and then we're going to look ahead to the future, and we'll see what that holds.
So, all the space shuttles line like airplanes too?
Yep. Yep.
And then can't like airplanes like transport them? I feel like I've seen.
Yeah, the thing is, when you get closer to space, airplanes lose their lift from the wings. So you really need the rockets to get them all the way up into orbit. There were ideas on how you might be able to do that, but they've proved fruitless when they look at all the physics. So there's Discovery one more time, and the last shuttle and the last thing you need to take notes on is Space Shuttle Atlantis. And write down, of course, that it flew the last shuttle mission back in 2011. Back when you guys were just wee lads and lasses.
So the space station or the telescope gets damaged, do you think they'll send up another one?
Well, the Space Shuttle program is officially retired now, actually. It is not going to be running again, but unlike just about every other astronomy class, this class ends a little bit differently. So here's Atlantis landing for the last time. There was a big celebration. Consequently, 2011 is when the 2011-2012 school year is when that's not when I started teaching. I started, I think 2011, 2012. I don't remember. It was either that or 2010, 2011. Either way, when the shuttle program ended is when I started teaching astronomy. So it's kind of like, hey, I'm here, and now astronomy is shut down for the United States. So anyway, there is some good things to look forward to in the future, though. You guys have heard of SpaceX, right? Yeah. So you don't have to write any of this down, but I just want to share some of this with you. This is different from the way this class ended in the past. The neat thing about SpaceX is you have reusable rockets here. And this is important because that means it's a lot cheaper to send these things up. Anybody have a guess as to how much it costs to send one space shuttle mission to space?
Just into space.
Yeah.
$1 billion.
$500 million.
Oh.
$500 million to get the space shuttle into space.
Wow.
Guess how much it costs for one of these rockets? Not $2 million, $50 million. So the space shuttle is 10 times more expensive to send up than what we're starting to send up there now. And this is SpaceX through Elon Musk and everything. Falcon 9 is probably the most famous rocket that they've been able to do this with. And they've sent some people up with this mission, famously docking with the space station and everything. But this is not going to be the future. This is the present. And Falcon Heavy is also part of the present. Falcon Heavy is basically Falcon 9 with 2 extra rockets on the sides. We've got 3 of those engines. It's the world's most powerful operational rocket, and it's 2 times more powerful than the second most powerful rocket. And here's some extra information on that. This is already a year or two old, so a lot of this is actually out of date already. But here's what it looks like from the bottom. You can imagine the amount of thrust that this thing gives off. 27 separate booster engines there. And this is it taking off. And of course, as these rockets take off and get into orbit, you have to have a curved trajectory. You don't want to just go straight up or you're going to leave the Earth and you're never going to get in orbit. So you would take this trajectory, eventually going in a big circle around the Earth. In terms of where this is all going, again, Falcon 9 and Falcon Heavy are the present. The future was called the BFR. They have since changed that to Starship. I actually don't remember. I don't know. Big Fat Rocket? Well, it's definitely with reason that they call it that. It was a big fat rocket. And basically, this is the big fat rocket down here. They would use this to get what looks kind of like a shuttle up into space, which would then take astronauts to places like the Moon and Mars. Mars specifically. The plan right now is that we are supposed to have people on Mars by 2036. That is the goal. Or actually, no, I think I said that wrong. I think it's 2026 is what his goal is. So,
There's no way.
yeah, 2026.
That's not good.
So this is, you know, what yeah, that's what they envision. Either way, the technology is here now more than ever to get humans to Mars. And so again, this is different. Keep it down a little bit, folks. This is different. Question?
No, I looked it up. They're only going to try in 4 years to send a ship.
4 years? 2024?
Elon needs to kill
Wow.
us sometime.
Well,
He already sent us part of that.
that's true. So, keep it down for a sec, guys. Let's just wrap this all up and put a nice little bow on it. So, you know, this is the vision of the future. One way or another, I'll tell you this, we're going to get to Mars. And when I was in high school, they told me, and I remember this, whoever's going to get to Mars first is in high school right now. They told me that. And that turned out not to be the case. If you look at the technology back then, we just weren't there. Right now, though, I can confidently say folks who are in high school right now are going to be on Mars in the next decade or two. So, why not you? If you're an exploratory person and you think this might be something cool, this is the sort of thing that will be available in the future. I can't say for sure. Obviously, some crazy things might go wrong. It is a super dangerous mission, not just getting there, but staying there. But I pretty much say with a high degree of confidence to myself that this is going to happen. And it's going to happen in our lifetimes. I strongly believe that. Yes?
It's probably a stupid question. How did they get the rotors to Mars? Did they just kind of like drop them off?
Yeah, I mean, they sent it in. They sent it on a big rocket, and that rocket would drop them in one of two ways. One way is they would drop it with a parachute, and the other way is they surrounded it in basically a big bunch of balloons, and it would bounce around, and eventually the balloons would deflate. Yeah.
So I was like, that was
Yes.
You go to Mars?
I would do it if they gave me the opportunity.
Even if there was no flight back.
Well, no, I wouldn't do it then. I want to come back. So, in conclusion, that is what astronomy is all about, Charlie Brown. Have a good one, folks. See you tomorrow. Rockets quiz tomorrow.
Did you watch the live stream or the last rocket that he sent out?